the nth term of a geometric sequence. So we've previously learnt about the rule to find the nth term, that is any term of an arithmetic sequence. We need to be able to do the same for a geometric sequence. So when we learned about the arithmetic sequence, we looked at the pattern of how we get Tn each term. T1 is, of course, the term at n1, and that is a. So we always let the first term equal a. Now, in a geometric sequence, the previous term gets multiplied by the common ratio. So to get term 2, we'd do a times r. Then to get term 3, we'd take a times r and multiply it by r again. So that would be a times r squared. Then we'd take the previous term and multiply it by r again. We'd get a times r cubed. So as you can see, in the same way as there was always this n-1 way of predicting the term, here the common ratio to the power of 1 less than the position, n, will find us the term, which means that the rule for the nth term of an arithmetic sequence is a, the first term, times r to the power of n-1. And this is the very important rule for the nth term of a geometric sequence. Now a couple of lessons ago, we did learn the arithmetic sequence nth term, and you'll see it's got some similarities. Tn equals a. It's plus for an arithmetic sequence and times for a geometric sequence. Make that a very clear times, even if mine was a bit wonky. R, the ratio in geometric, whereas it's the common difference. These are next to each other. They've got an invisible times sign. You can always write that with a times sign between the bracket and d. And here, the arithmetic sequence is n-1 in brackets times d. Here it's r to the power of n-1. I can almost guarantee you that one of you is going to be writing really messily on a test because you're in a hurry and you're going to be aiming for the geometric sequence and you're going to write Tn equals a times r n-1. Oh my god, I'm in a hurry, and you're going to forget that that's not a power. You're going to think this is r next to n-1 and you're going to think that's times, not power. This is not a good thing. Write these neatly if it is the last and only thing you do. R is to the power of n-1. In an arithmetic sequence, it's n-1 times the difference. We'll write in again all of these, n, tn, a, and of course for the geometric sequence, r. So, I know you know it, but we need to know it so well. N, position of the term in the sequence. Tn is the actual term of the pattern that's in position n. A is the same as T1, which is the first term, and R is the common ratio, which you'll remember is T2 divided by T1. Now, when we learned about the nth rule before, or the nth term, there were two different sorts of questions. One just wanted a rule for this pattern to find the nth term, that is to find any term, so that you had the rule ready. So if someone came back and said, find me the 487th term of this sequence, you had a rule ready to go. So we start with the formula. Tn equals a times r to the power n minus 1. Always start by writing down n, Tn, a, and r, the 4 variables in the formula, and work out what you know. Now for n and Tn, you don't know these because you're waiting for the mystery person to turn up and say, I want term 47. And if you want term 47, then you know that n is 47. But until you know that, we don't know these two. But a, first term, is 2. R, common ratio. Now, very important thing. They've told you this is geometric. They've given you a present because they've said it's geometric, so you don't need to prove it. So you can just take the two smallest numbers, T2 and T1. T2 divided by T1 is 14 divided by 2 equals 7. Check that you haven't done it the wrong way around like I did last video. 2 times 7 is 14. 14 times 7 is probably 98. That sounds good. Okay, if they hadn't said geometric, if the question was that, you'd have to prove it's geometric first, which is a real pain. So we've found that we don't have n and Tn because it's just an nth term question. And we've got these. We have our rule. So Tn equals, substitute in A, 2, times, substitute in R, 7 to the power n minus 1. So Tn and n both stay in the rule. And this is it. That's the answer for the rule for the nth term. Because they're just saying, please write me a rule so you can work out any term in this sequence when someone tells you what they want. So, in fact, if there had been I'm just going to sneak an extra question in here. Pretend it was always there. Now use your rule to find T47. That's going to be pretty painful. Let's make it term 7. Because I've only got a scientific calculator with me. Term 7. So now we know what n is. Now they're saying use this rule to find term 7. Term 7 is 2 times 7 to the power of n minus 1. N is 7 now. 7 minus 1 is 6. You grab your calculator. 2 times 7 to the power 6 equals 235,298. Oh, by the way, geometric sequences go up very, very fast. So, let's pretend I had that question the whole time. It's a good question. This is the other sort of question that we did for the arithmetic ones. Find T15, the 15th term in the geometric sequence like this. So, that's when you need your rule. Tn equals a times r to the power n minus 1. Write down all of these. N, Tn, a, r. They want the 15th term, which means n is 15. They want me to find Tn, but I'm going to redefine that as T15 and still say I don't know it. So when I substitute in the rule, I'm going to say I want to find T15, but my overall goal is to find out what that is. I know A, the first term, that's 3. They've told me it's geometric, thanks people. So I only need to do T2 over T1 equals 6 over 3 equals 2. Do show you're working for this, please. Even though it's obvious, that's times 2. Show you're working. Substitute in your known values. Now you are going to substitute in T15 because we're saying we really want to find T15. A, 3 times the common ratio of 2 to the power. Now you don't need to write 15 minus 1, because I'm pretty sure you can manage 15 minus 1 is 14. And then to evaluate T15, 3 times 2 to the power 14 is 49152. And that was T15. You've found the 15th term.